In this lecture, we're going to discuss and learn about covalent compounds. Now, the first thing about covalent compounds is that covalent compounds are formed between one nonmetal and another nonmetal. So this is the first point. They're formed between nonmetals. Now, nonmetals, if you have the periodic table with you, they start from group 4. You have group 5, group 6, and you have group 7. So roughly speaking, I've already given you previously. I showed you a periodic table, and I told you that there was a staircase. On the right of the staircase, you had non-metals, and on the left-hand side of the staircase, you had. In this lecture, we're going to discuss and learn about covalent compounds. So covalent compounds, instead of losing or gaining electrons and forming ions, they instead share electrons. The first thing that we need to learn is that covalent compounds are formed between non-metals and other non-metals. So they are bonds that are formed between non-metals and non-metals. Now, if you have the periodic table with you, you can look at the periodic table and you can I'll tell you, non-metals are on the right side of the periodic table. There's a staircase formed starting on top of aluminium, and it keeps on going like this. Now, the elements that we're starting from group 3. These two elements belong to group 4, then group 5, group 6, and then you have group 7. So elements on the right side of the periodic of this staircase line, these are broadly classified as non-metals. So you're going to find non-metals on this side. The ones on the left hand side are all metals. So covalent compounds are found between elements which are all non-metals. Now I'll start off with an example. For example, I have fluorine, and I have one fluorine and it is trying to bond with another fluorine. So fluorine is 9 and its atomic mass is 19, which means that it has 9 electrons. So if I draw a molecule, an atom of fluorine, I'll have 9 protons and 10 neutrons in the nucleus, and there would be 2 electrons in the first shell that I'm drawing right now. So there would be 2 electrons in the first shell, and there would just be and there would be 7 electrons in the second shell. Now, if you look carefully, fluorine it's an unstable electronic configuration. So fluorine needs 1 electron. Fluorine requires 1 electron to complete its outer shell. I'm going to draw another fluorine atom over here. This here is the nucleus. It's going to have 9 protons and 10 neutrons as well, and there would be 2 electrons. There would be 2 electrons. I'm drawing those 2 electrons by crosses, and there would be 7 electrons in its outermost second shell. So there are a total of 7 electrons in its outer shell. So both of these fluorine atoms are identical, and the problem is that this fluorine also needs 1 electron to complete its outer shell. What's going to happen is that this fluorine would try to pull this electron from the other fluorine atom to complete its outer shell. On the other hand, the other fluorine atom would try to pull an electron from this fluorine atom to complete its outer shell. Obviously, what's going to happen is that both atoms would try to pull each other's electrons towards themselves, and which will and they will end up sharing these two electrons. So redrawing this, that's one atom, and here's the second atom. I've drawn the two atoms close together now. Now those two electrons in the center are now being shared. One is a dot and the other one is a cross, and those two electrons are now being shared, whereas the list you have, if you look, one electron is now shared and you have 6 electrons remaining. On the other hand, for this fluorine atom, there were 7 electrons in its outer shell. One is now shared, and you have a total of 6 electrons remaining. Now, when it comes to Cambridge questions, generally the question states that you just need to draw the outer electrons, the outer shells. So I'm ignoring the inner shells, the 2 electrons over here and the 2 electrons over here, when I'm drawing the dotted cross diagram for fluorine. So I'm just going to label this as fluorine. This would be the other fluorine atom, and the dotted cross diagram would look like this when we are only trying and we are only going to show the outer electrons. So 2 electrons are shared. This fluorine needed one, so it pulled 1 electron from this fluorine. This fluorine needed 1 electron. It tried to pull an electron from this other fluorine. Eventually, the 2 electrons ended up between these two atoms, and that they are now being shared. One way to check whether your covalent dot and cross diagram is correct is by counting the total number of electrons around one fluorine atom. If you count, this is 1, 2, 3, 4, 5, 6, and 7, and 8. Counting the one that is shared as well. So we are including that as part of this fluorine. Similarly, if you count the number of electrons around this fluorine atom, you'd see that there are a total of 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. So this is the dot and cross diagram for a covalent compound, which would be called, it would be called F2. 2 would be written in small, which would indicate that the two atoms are joined together. Similarly, we can do another example, and this example there would be two nitrogen atoms. Nitrogen is 7 and 14. There would be two nitrogen atoms. Both of them are non-metals. They are part of group 5, and they are trying to join with each other, chemically bond with each other. Now, nitrogen's electronic configuration. Let's draw a nitrogen atom first. There would be 7 protons and there would be 7 neutrons in nitrogen, and there would be there would be 2 electrons in the first shell of nitrogen, and there would be 5 electrons in its outer shell. We can draw another nitrogen atom as well, and this nitrogen atom has 7 protons and it has 7 neutrons as well. It is identical, and it has 2 electrons in its inner shell, and there are a total of 5 electrons in its outer shell. Both electronic configurations are unstable. This nitrogen needs it needs 3 electrons. Similarly, this nitrogen also needs 3 electrons. Again, the problem with non-metals is that no atom is willing to actually give electrons. So what happens is that this nitrogen over here, it's going to try and pull this electron towards itself, this electron towards itself, and it needs 3 electrons. So it would try to pull this electron towards itself as well. On the other hand, this nitrogen would try to gain 3 electrons as well. So it's going to try and pull these 2 electrons towards it, and it's also going to try and pull these this one electron over here. So both nitrogens are going to try and pull 3 electrons each from each other. What happens is, let's draw the covalent diagram now. What happens is that I've drawn the outer shell of two nitrogen atoms. This is the first one and this is the second one. And what happens is that since both of them were trying to pull 3 electrons each from each other, so in the center there would be 6 electrons that would then be shared between the two. So there would be one electron coming from this nitrogen, a second electron coming from this nitrogen, and a third electron coming from this nitrogen. Whereas from this nitrogen there would be 1 electron, 2 electron, and 3 electrons. So a total of six electrons would be shared. And if these 3 electrons over here and these 3 electrons over here are shared, there would just be 2 electrons remaining with each, which would not be taking part in the sharing process. So there would be 2 electrons remaining with this nitrogen, there would be 2 electrons remaining with this nitrogen, and in the center there would be 6 electrons that would be shared. So 6 electrons are shared between the two nitrogen atom, and I'm only drawing the outer shell. So only the outer shells are drawn. Another example that we can do is of oxygen. So you have oxygen, which is represented by O, and oxygen has the proton number is 8 and the atomic mass is 16, so that means it has a total of 8 electrons. So let's draw an oxygen atom. This here is the nucleus of an oxygen atom, which is going to have 8 protons and it's going to have 8 neutrons. There would be the first shell would have 2 electrons, and there would be there would be 6 electrons in its outer shell. So the electronic configuration would be 2 and 6, and there would be another oxygen atom with the same electronic structure identical to it. It would have 8 protons and 8 neutrons, and the first shell has 2 electrons. This is drawn with crosses, and the second would have a total of the 6 electrons. So the total of 6 electrons in the second shell, in the second oxygen atom. Now, both of the electronic configurations are unstable. This atom needs 2 electrons, and similarly, this other oxygen atom also needs 2 electrons. Now, both oxygen atoms need 2 electrons. What this oxygen would try to do is it's going to try and pull these 2 electrons towards itself. Similarly, what this oxygen atom would try and do is it's going to try and pull these two electrons towards itself. And eventually what's going to happen is that these 4 electrons are going to be shared between the two oxygen atoms. Now redrawing and showing that, I'm only going to draw the outer shell. So I've drawn 2 overlapping atoms, both are representing oxygen. I'm only drawing the outer shell. So what happens is that there are a total of 4 electrons shared between the two atoms. And since 2 electrons are shared, the number of electrons that are left behind, that's 1, 2, 3, and 4. So 4 electrons are left behind in the outer shell. Similarly, this oxygen atom would also have 4 electrons left behind, which are not taking part in the sharing process. So this is one oxygen atom, this is the other oxygen atom, and this represents the dot and cross diagram for an oxygen molecule, which would be represented by O2, and 2 would be written in small, which signifies that the two atoms are chemically joined together. Now, there are certain rules that we can come up with which would help us in drawing the dot and cross diagrams for covalent substances. One of that rule is that the first rule is that electrons are always shared equally. What that means is that if one atom is sharing one electron, then the other atom would also share one electron with it. If one atom is sharing three electrons, then the other atom would also share three electrons with it. For example, if you look at the oxygen molecule where there's one atom which is sharing two electrons and the other atom is also sharing two electrons. And rule is the second rule is that group 7, if you're a group 7 element, you would always have 7 electrons in the outer shell. That would mean you would need one electron to complete its outer shell. So the amount of electrons that are needed, that's the same amount that would be shared by that atom. So group 7 elements would share one electron. If you're a group 6 metal, you would have 6 electrons in the outer shell and you would need 2 electrons. That would mean that you would share a total of 2 electrons. Similarly, if you are a group 5 element, you would need 3 electrons to complete the outer shells. So group 5 elements would end up sharing a total of 3 electrons. And if you are part of group 4, you need 4 electrons to complete the outer shell. So group 4 elements would end up sharing a total of 4 electrons.